We had attempted to capture perhaps some of the entry aerodynamic testing that we were going to be doing with the Shockwave on Columbia. And this, of course, pictures us on the morning breakfast before launch, and we tried to wear a different shirt each day so that we'd know just which attempt this was. And as I'm sure you'll recall, we went through 5 man-ups before we finally managed to launch. This is the actual morning that we finally did launch. We were getting very good at this procedure, walking out to the crew van, and actually we got very good at walking back from the crew van too, I'm afraid. Bill Nelson obviously very ready to go on this particular day. We manned up in the early morning darkness, aiming at a 6 a.m. liftoff.
We did lift off, I think, about 6:55 in the morning, and as a first-time guy, I must say that I thought Hoot and the other experienced guys had me quite well prepared for what we were about to encounter. You know, it seemed pretty calm and collected there until the main engines lit, and I got a slight glow off the from the outside, but when the solid rocket boosters ignited, I knew that I was in for a rude awakening, that all my preparation, you know, I don't know whether it was going to stand me in good stead or not. We did the roll program and right away got an alarm. So that put me at ease because I thought right away, oh, it's just like being in the simulator, and that set the tone for the rest of the ascent. It was very, very impressive as a first-time flyer. We lifted off in darkness and then started seeing sunlight almost right away when we got heads down. We finally got to an altitude of about 61 miles when we had the main engines cut off, and that was almost 8.5 minutes later. We did have only 2 alarms during the ascent. Both of them turned out to be old sensors and no real big problem. The most impressive thing to me about the ascent from a physical point of view was the force that was exerted during the 3G throttle down close to the main engine cutoff. There you saw the solid rocket booster separation. I had planned to do a lot of reach and visibility checks, and in feeling the force on my chest, I just said, well, forget about that. I'm going to sit here and enjoy the ride. People that were at the Cape said that they thought the launch itself was spectacular.
I guess the thing for me was the impression of first getting unstrapped from the seat and getting ready to the environment of weightlessness. And here are some scenes of people just getting used to this new environment, which was truly new for me and Charlie. And of course, on the first day, the first thing that we had to do was kind of get our minds set for the deploying of the satellite that we had to do later on that day. What you see here out the window, out the back window, is of course the familiar sun shield that later on gets open, and the satellite inside of it is made to spin. And here are some of the operations in the cabin getting ready to launch that satellite. It really is a coordinated team effort, even though Pinky and I were the had our primary responsibility to deploy the satellite. It really is a team effort. The orbiter has to be precisely pointed in just the right attitude and with no motion, so that the satellite doesn't get an additional kick in a wrong direction. And Pinky and I work together. Everybody backs everybody else, and of course the satellite is released in a spinning motion, which allows it to maintain the orientation that the orbiter imparts it. We were looking for any signs or any telltale signs of wobbling in the satellite, and of course we found none. We kept tracking that satellite with the cameras and zooming in and out in the nozzle portion of the satellite to make sure that there was no indications or any signs of wobbling in the satellite, and it was just steady as a rock. And of course, a timer is set as soon as the satellite leaves the cargo bay that will ignite the PKM motor later on the other side of the Earth.
Hoot had mentioned the number of getaway special canisters we had on board. It was 13, and they were all controlled with this controller that you see me holding in my left hand. And what we do is to set the status of a variety of different relays which apply power and make functions happen for the different getaway special cans, 3 of which were the ultraviolet astronomy experiment, which you may remember from our pre-flight conference I was quite interested in. As Franklin mentioned in connection with the SATCOM deployment, the UVX is also a team effort, and it required one of us to operate the controller and one of us to make sure that whoever was operating the controller did it right, and then Hoot and Charlie, you see here in the forward flight deck, had to point the orbiter and therefore the telescope in the proper direction so that we could take the data, and we're all looking forward to getting a report on how that went. Of course, all that data is recorded on board, and so we're not sure yet exactly how much data we were able to take for the experimenters.
We had a number of other space science experiments to do on board. On the first day, we started up the material science laboratory and got it running. It was pretty much an autonomous machine, ran throughout the flight, or it was supposed to run throughout the flight. Another of our projects was to try and take some photographs of Halley's Comet. Unfortunately, the photomultiplier that we had to do that was not working. We attempted to take some photographs. Unfortunately, due to our orbit and the orbit lighting, we were unsuccessful.
Yeah, one of the other things we were doing is shown right here. Charlie and I, Charlie did most of the operation on the IR-IE camera while I was looking out the window and watching on the monitor, which is up in the corner and you can't really see it too well there. Watching the scenes out the window, and especially Hoot was helping out here a lot, looking down to compare what we were seeing on the ground, because when you're looking in the IR on the monitor, it doesn't look like the real world, and trying to direct Charlie as where to point the thing.
You take a lot of viewing of the world, and we had some time on this flight to do some pretty extensive Earth observations. We obtained a number of pictures that had never been taken from space before, of places on the Earth. And as a veteran, I can tell you, you never get tired of seeing the world. This is the Irrawaddy River Delta down in Thailand, and the city of Rangoon there is just on the eastern side of that. And then we continue to pass. We had some very rare passes over Southeast Asia where the weather was unusually clear. Got some fantastic and unique pictures of that.
This was a shot coming up on this is the west coast of Australia that's coming up here, and this is the Beagle Islands. We were always interested in watching the Beagle Islands because it seemed like every time we'd come by there, we'd have internal waves that we could see in the water. And we were looking at some the day that we shot this 16 millimeter. Unfortunately, they don't reproduce in the 16, but we nevertheless got quite a few good 70 millimeter photos showing a lot of wave action happening around these islands and off the western coast of Australia.
This was a shot made later in the flight coming across the Indian subcontinent and looking north into the Tibetan Plateau and across the Himalayan mountains. We did get a number of 70 millimeter still shots of the rare clear days over the Himalayas, but it's an absolutely awe-inspiring sight. Come drifting across the Himalayas at 5 miles a second and to see no clouds in sight.
An interesting thing to me about Earth observations was being a pilot. It seemed visually like you were flying in a regular airplane, you know, at 41,000 feet or so. The one thing that reminded you of where you were was the fact that, for example, crossing the United States in 10 minutes. I had never been in an airplane that could do that, so that was the one thing that gave you the rude awakening that you were way up there.
This is an area in the world near New Caledonia and is typical of the kinds of coral atolls that you can see, particularly in the South Pacific. Pinky had mentioned as a veteran that you never get tired of looking out the window, and I guess my observation, based on having flown previously, was that not only do you not get tired, but the second time you do it with an experience, I think, which tends to produce perhaps better data the second time. You learn a bit more about how to do the task of Earth observations, and you'll learn a bit more about what the Earth looks like, and it was surprising to me how easy it was for me to recognize different features of the world that I had difficulty with on my first flight.
Here's the Horn of Africa, and it was sort of interesting for me that after a few days all these things become so familiar, having never been overseas, and I used to tell myself what a way to go overseas. A lot of activities in cabin. You can see that everybody's doing something here, and I tried to set up was to have one person, for example, be in charge of loading all the cameras and making sure that the cameras were ready to go and had the proper exposure set and all that. And that was my job. I was supposed to keep all the cameras in good shape, and here is the loading of some of the 16mm film in the Aeroflex camera. And by God, we shot every bit of film that we had.
Franklin did a great job, except he let us run out of film by the end.
Yeah, by the time we ended up the mission, we were down to the black and white 35mm film.
I might mention we had a brief shot there of Congressman Bill Nelson on the middeck. Bill was just as busy as he could be every single time that anyone passed through the middeck, and we've probably omitted Bill a little bit during the movie, but we have quite a few slides that we're going to ask Bill to address once we get out of the movie.
In that last scene, he conscripted a little help from me with one of his experiments to do some eye-hand coordination, which is over and above the original experiment, DSO, which I was involved in, which was otter goggles. It's one of the things they're trying to examine to decide whether or not there is indeed what the relationship is between the space adaptation syndrome and how we could possibly train people for it. And unfortunately, we had a little problem with the goggles early on in the mission, but in this scene, Pinky and I disemboweled it and put it back together, and it got it working again so we could continue with the experiment.
Every time you have a new vehicle, we're interested in seeing how it expands and contracts when it gets into space. So what we're doing right here is actually conducting cabin measurement. We measured the separation between the lockers, the distance between the floor and the ceiling, and everything else of that nature, and we do that on each new vehicle. So Columbia was kind of considered a new vehicle this time, and we redid the cabin measurements.
Bill Nelson had a treadmill test that he was going to be running on the last day of the mission, and a few of the rest of us managed to use the treadmill during the flight, and that was a quick shot of me getting a few minutes on it.
On my first flight, you may remember we had Charlie Walker and his Cephas machine, which goes in place of the galley. So one of the nice additions to 61C, at least as far as I was concerned from the habitability point of view, was a galley, which makes food preparation a lot nicer task, particularly with a 7-person crew. In addition, since I had previously flown on a crew that was slightly smaller, I learned that at mealtime it takes some amount of innovation and adaptation to find a place to eat where you're not in somebody's way. And so we took some pictures just to show you where different people elected to eat, and it didn't seem to be in the same place every day. We did try to eat together as a crew, at least for the evening meal, and that seemed to work very well, and it was a nice time for us to review what had happened during the day and to discuss what was coming up next, which always seemed to me to be re-entry. It seemed like we were always talking about re-entry. You can see Bob found a comfortable corner in which to stuff himself there, where he was able to keep most of his food under control.
Of course, I wasn't always trying to.
And this was a pretty good spot. What you really needed was someplace you could jam yourself in and hold still to get through the meal.
Cabin stove was something we got to practice started practicing at about midway through the mission. And we got pretty good at it. I guess this is Steve trying to battle there with one of the cables.
We thought we had given you what we hoped was pretty decent in-cabin TV, and we apologize for the lack of in-cabin TV for the last two or three. We'd stowed the camera away, so we didn't break it back out again.
After 300 hours of spaceflight, you can really learn how to adapt yourself to zero-G and do the tasks a lot more rapidly than you ever could on the ground, and most of the things like stowing the cabin were really no problem at all.
With some exception.
Almost stowed.
Cables develop a mind of their own.
This helps you understand why we didn't break the camera back out.
The real difficulty of this scene was holding the camera still while he was trying not to giggle at Steve.
I had no interest in getting that out again after.
This is another activity that we really did spend quite a bit of time doing with our three practice attempts to deorbit and land, was cleaning the cabin up. We tried to make sure that we returned a relatively clean orbiter when we came back down to land, and this shows Steve and Franklin and Bob and Charlie cleaning the bird up and trying to get some of our coffee stains and things like that off the orbiter so we could bring him back a relatively nice bird.
thing that's really amazing to me was the fact that, you know, having been on an aircraft carrier for brief periods of time, Hoot and I being associated with the Naval Service, it's like being in a city. You know, it doesn't look like that, but it really is. We're, I guess the third time was the charm for us. We had tried to get down and tried to get down, and finally this was real entry morning. We were able to catch a final glimpse out the back windows of another sun. I think this was a sunrise right over the vertical tail. You can't see it very well, but we had the shuttle imaging infrared lee-side test stuff up on the pod. This is actually the landing itself. The entry was spectacular.
Unfortunately, there wasn't a whole lot that we could film on the landing because it was all dark, so the only footage that we had was when the orbiter actually came within view of the big lights down on the ground, our xenon lights. Touchdown was about 1,500 feet down the runway at Edwards. The orbiter was very smooth handling, very nice and responsive. The nose gear steering was used a little bit through the landing roll. Not a very big input, but just a little bit of nose gear steering prior to brake application. We got on the brakes just below 140 knots, held a relatively constant 8 feet per second squared deceleration rate until we got wheel stop. I guess we used something like 11,500 feet of the runway in getting stopped. We understand that we perhaps had a little bit of brake chipping on the right outboard brake, but other than that, we don't have a whole lot of reports of brake damage, so I think the brakes people are relatively pleased with how the brakes held up and how the wheels and tires made out on this. We came popping out probably about 45 minutes after touchdown. The cabin was a little bit warm by the time we got out, so the cold morning desert air at 32 degrees felt real nice to me, and I think all of us were happy to be back on the ground again. Even though spaceflight is a wonderful experience and we enjoyed it after all the practice attempts to get down, we were happy to be back.